So we're picking up our notes from yesterday. We're going to start with the problem here. This one. Oh, my daughter's changed to a lightsaber. We have 3x to the 8th, y to the negative 4 squared. So everything inside the parentheses is being repeated. So I'm going to rewrite this as 3 squared, right? What do I do when I raise a power to a power? Power to a power, we multiply. So 8 times 2 is 16. And y to the negative 4 times 2 is negative 8. Now I can simplify 3 squared, right? I get 9 x to the 16th. And what happens to the y to the negative 8?
It goes in the bottom.
It goes in the denominator.
Okay, so besides the fact that I forgot to square the 3, I did right.
Good. Okay. Let's just go down because these ones are pretty simple. 4 to the 7th divided by 4 cubed. Now, these ones we put on the quiz to make easy problems, easy points, and people miss them all the time because they divide the bases. The base doesn't change. Okay, so I subtract my exponents, right? 4 to the 4th power. That's it. It's 4 to the 4th. You can write it as 256 if you want, but that's what we want you to know, that the bases don't divide. Because remember, that's 7 4s on the numerator and 3 4s in the denominator. What you're multiplying over and over again didn't change to 1s. You're still repeating the multiplication of the number 4. Okay? Yes? No. These are your notes. Then, yeah.
The only time the bases do change, though, if the two numbers are different, they're not the same.
If the bases are not the same, you cannot combine them unless you can do it. Like if you can do 2 squared times 3 squared, you have to make that, you have to simplify it. You can't put them together if the bases aren't the same. Okay, so if you can't make that 6 to the 4th. It's not the same answer. Right? If I said 2 squared times 3 squared, you can't multiply the bases and add the exponents. You'd have to make this 4 times 9 to simplify that. Okay? All right, number 17 here. This problem, I start by subtracting my exponents. I get 8 to what power? 6. To the negative 6. And that is 1 over 8 to the 6th. Correct. If it's just a number by itself, one term by itself and has a negative exponent, I have to put the 1 as the numerator.
Because the negative exponent has to be the denominator?
Correct. Yes, the negative exponent has to be the denominator. There has to be something in the numerator. All right, let's look at 14. So 14 has a lot going on. Let me zoom in. Okay? Pay attention to this one. There are several ways to do this problem. I prefer, when I've got a bunch of stuff going on in the parentheses, I like to work with smaller numbers. So I like to simplify what's inside first and then apply what's outside if possible. Okay? So let's simplify the inside by subtracting our exponents. 2 minus negative 5. Right? Yes, minus negative becomes plus, so that becomes x to the 7th. And then it's negative 3 minus 7, y to the negative 10th. All to the negative 6th power. Now, could I write that instead? X to the 7th over y to the 10th to the negative 6? Yeah, that's the same thing, right? Those are equivalent expressions. I can do it either way. I can multiply the exponent here and then deal with the negatives, or I can write it as a positive exponent in a fraction and then deal with the negative exponent and apply it. What does the negative exponent do to the fraction like this? It flips the fraction. Okay? Remember that the negative exponent does not make anything negative, right? It makes the fraction flip around. Okay? So if I'm doing it this way, It's x to the negative 42, y to the 60th. Well, negative 6 times 7, negative 6 times 10, which would be y to the 60th over x to the 42nd. Would I get the same thing if I flipped the fraction and then multiplied by 6? Yes. So it's y to the 10th over x to the 7th. In this way, x to the 7th to the 6th. Took care of the negative. I already took care of the negative by flipping it.
Oh, right.
And then y to the 60th over x to the 42. I get the same answer. It's going to be up to you to decide which way makes more sense to you. Okay? All right, and then look at 13.
Whoa. The 13's a lot of numbers.
Now we're getting really down to what we need to be able to do for this class. Okay, can we really simplify the complicated ones? Now, my recommendation, the way I like to do it, is simplify the top, multiply across the top, combine that, combine the bottom, and then simplify up and down. Okay? You have to do exponents first as well. So if there was parentheses in an exponent, you'd have to do that, and then you could combine. So let's do the top first, okay? I'm not going to write 36. I'm just going to write it as 4 times 9. It's going to make it easier for me to simplify the fraction in the end. Okay? What do I get with my a's? A cubed times a to the 5th. A to the 8th. And b times b squared. B to the 3rd. And my denominator, 3 times 6. A to the negative 2 plus negative 6. A to the negative 8. And b, 4 plus negative 8. Negative 4. Now, can I simplify this part? Well, isn't this 36 over 18, which is 2? Okay, so I get 2. And I have a to the 8th. Can I move this one up? A to the 8th? Because I have a negative in the bottom. That moves it up, doesn't it?
Wait. Oh, yes, so there's 2 A's.
And then I can move up the b. B cubed and b to the 4th. So a to the 16, b to the 7th. Now, could have I subtracted 8 minus negative 8 is positive 16, right? If I had done the subtraction here, 8 minus negative 8 gives me positive 16. 3 minus negative 4 gives me positive 7.
Okay, I actually that.
But we really have to be super careful with the double negatives, right? Subtracting those negatives in the bottom, you've got to really pay attention to that.